I'm Holly Markovich, and this is MAT 171 Pre-Calculus Algebra. This is a short video on obtaining information from graphs. So as we begin this presentation, let's decide what information we can obtain from a graph. First and foremost, I believe that all of us would want to be able to look at our graph and say whether or not it is a function. This is something we've learned in a previous lesson, but is very important here. We can also determine the domain, the range, intervals where the graph is either increasing or decreasing, and whether the graph has an absolute maximum or minimum, or just local maximum or minimums. Let's start with a basic polynomial function. Would you be able to determine the domain and range of this polynomial function? When we look at our graph, we can see that it is continuous from left to right, picking up all of our x values. Therefore, our domain would be from negative infinity to positive infinity. When we think about range, here we're thinking about the y values, or from bottom to top, we're picking up all of our y values, and therefore our range is also negative infinity to positive infinity. These are both written in interval notation, and we're pretty comfortable with this. Now that we have written our domain and range in interval notation, let's take a look at where our graph appears to be increasing or decreasing. A quick reminder here, when we read graphs, we read our graphs from left to right. And because we're reading our graphs from left to right, we're basically looking at our x values for writing intervals. Let me show you what I mean. If you take a look, as we come in through our x values from negative infinity, it appears that our graph is going up. It looks like our graph is increasing in value until we get to the value of negative 1.291. It also appears that at 1.291, our graph starts to go up again. Let's decide how we would write that in interval notation. Take a look what I've written here as the intervals of increase. Notice that I've said from negative infinity to negative 1.291, those are x values, union with positive 1.291 to infinity. Now let's look at intervals of decrease. We can see that the graph appears to be going down from negative 1.291 to positive 1.291 for our x values. Let's write that in interval notation. Hopefully, you wrote negative 1.291 to positive 1.291. This would be the interval on x where our graph is going down or decreasing. Now let's determine whether or not our function would have absolute maximum and minimum values, or if it would have local maximum or minimum values. Function values come from the range of the function. If we take a look at our range, we can see that our range continues through infinity, and it came in from values negative infinity. So we're not going to have any absolute maximum or minimum value. What we will have are a local maximum and local minimum. Now, in this graph that we're examining here, they're spelled out pretty clearly. Sometimes we could have more than one local maximum or minimum. These are determined from where our graph goes from increasing to decreasing, or where it goes from decreasing to increasing. Notice in this first path, our graph hits a maximum value of 6.721, and then it goes down. At 6.721, that is a local maximum. Here, where our graph goes from decreasing and it turns to increasing, we're going to have a low point in that graph, and that will be the local minimum, 3.279. I hope that through this basic presentation, you're able to look at a graph, determine whether or not, first of all, it is a function, and if it's a function, you can find the domain, the range, where the graph is showing intervals of increase or decrease, and whether or not the graph has an absolute maximum or minimum, or whether it has local maximum and minimum values.